Space, the vast and seemingly empty expanse that surrounds our planet, has always fascinated humanity. It is a vacuum, devoid of air or any significant atmosphere. But have you ever wondered what would happen if space was filled with air? In this article, we will explore the hypothetical scenario of a universe where space is no longer a vacuum but instead filled with air. Subscribe now. The nature of space. Before we delve into the implications of a space filled with air, let's understand the nature of space as we currently know it. In our universe, space is mostly empty, characterized by an extremely low density of matter, including gas particles and dust. It is a vacuum, meaning it lacks a significant atmosphere and pressure. This unique characteristic allows for the propagation of light and other electromagnetic waves, making it possible for us to observe distant stars and galaxies. The implications of filled space. If space were filled with air, it would introduce several profound changes to the nature of our universe. Here are a few notable implications. Atmospheric pressure. The presence of air would result in a substantial increase in atmospheric pressure throughout space. In contrast to the vacuum of space, this pressure would create a resistance to the movement of objects and alter the way celestial bodies interact. Spacecraft and satellites would experience air resistance, which would affect their trajectories and require adjustments in their propulsion systems. Heat transfer. The introduction of air would allow for heat transfer mechanisms such as conduction, convection, and radiation to occur in space. This could impact the thermal management of spacecraft and other objects in space. Heat dissipation would become more efficient, but it would also necessitate enhanced cooling systems to prevent overheating. Sound propagation. With air filling the space, sound waves could propagate, enabling the transmission of sound. However, the absence of molecules in the vacuum of space currently prevents sound from traveling. This change would make it possible for astronauts and spacecraft to hear sounds, creating a new dimension to the experience of space travel. Stellar dynamics. The behavior of stars and galaxies would be significantly altered if space were filled with air. Stellar processes, such as nuclear fusion within stars, would be affected by the presence of air particles. This could potentially lead to changes in the life cycles of stars and influence the formation of galaxies. Interstellar travel. The presence of air in space would present new challenges and opportunities for interstellar travel. While the increased atmospheric pressure could impede spacecraft acceleration, it could also provide opportunities for aerodynamic maneuvers and new propulsion techniques, leveraging the air's properties for efficient movement through space. Conclusion. While the idea of space filled with air may seem intriguing, it is important to note that our current understanding of the universe is based on the vacuum of space. The hypothetical scenario of a universe with air-filled space would have far-reaching implications, impacting the behavior of celestial bodies, space exploration, and our understanding of the cosmos. Exploring such hypothetical scenarios helps us grasp the complexity and interconnectedness of our universe. Although it may remain a thought experiment for now, who knows what scientific discoveries and technological advancements the future holds that could potentially transform our understanding of space and open up new possibilities for exploration beyond what we currently conceive as possible. Challenges and considerations. While the concept of space filled with air opens up intriguing possibilities, it also poses significant challenges and considerations. Some of these include: atmospheric composition. The composition of the air filling space would play a crucial role in determining its properties and effects. Factors such as the presence of oxygen, nitrogen, or other gases would influence the behavior of objects, heat transfer mechanisms, and the overall dynamics of the universe. Pressure gradients. The distribution of air density and pressure would not be uniform throughout space. Gradients in pressure would exist, and these variations could have a substantial impact on the movement of objects and the behavior of celestial bodies. Understanding and navigating these pressure differentials would be essential for space exploration and travel. Human survival. The presence of air in space raises questions about human survival and the requirements for sustaining life. The atmospheric composition, temperature, and pressure would need to be within certain ranges for humans to survive without the aid of spacesuits or enclosed habitats. Adequate protection against radiation and other space hazards would also be necessary. Astronomical observations. The introduction of air into space would affect astronomical observations and our ability to observe the universe. The presence of air particles could scatter and absorb light, leading to changes in the appearance and clarity of celestial objects. Observatories and telescopes would need to adapt to these new conditions to ensure accurate and reliable data collection. Impact on cosmology. The presence of air in space would have profound implications for cosmology, the study of the origins, structure, and evolution of the universe. Fundamental concepts such as the expansion of the universe, cosmic microwave background radiation, and the formation of galaxies would be influenced by the new dynamics introduced by the presence of air. Conclusion. Imagining a universe where space is filled with air stimulates our curiosity and challenges our understanding of the cosmos. While this hypothetical scenario introduces intriguing possibilities for space exploration and the behavior of celestial bodies, it also presents significant challenges and considerations that would need to be addressed. As we continue to explore and push the boundaries of our knowledge, it is essential to recognize the limitations of our current understanding and the speculative nature of such scenarios. However, by engaging in these thought experiments, we expand our thinking, stimulate scientific inquiry, and pave the way for future discoveries and breakthroughs. The universe, in its vastness and complexity, holds countless mysteries yet to be unraveled. While space remains a vacuum for now, it is through our exploration, curiosity, and relentless pursuit of knowledge that we inch closer to understanding the wonders that lie beyond our home planet. In conclusion, contemplating a universe where space is filled with air opens up a realm of possibilities and challenges our understanding of the cosmos. While it remains a hypothetical scenario, it stimulates our curiosity and fuels scientific inquiry. The introduction of air into space would have profound implications for space exploration, the behavior of celestial bodies, and our understanding of the universe. It would reshape the dynamics of objects in space, influence heat transfer mechanisms, and potentially alter the formation and evolution of stars and galaxies. However, it is important to recognize that our current knowledge is based on the vacuum of space. The hypothetical concept of air-filled space raises numerous considerations and challenges that would need to be addressed, ranging from atmospheric composition and pressure differentials to human survival and technological advancements. As we continue to push the boundaries of scientific exploration and technological innovation, we inch closer to unraveling the mysteries of the universe. The idea of space filled with air serves as a reminder of the endless possibilities that await us and the transformative nature of scientific discovery. While we may not see space filled with air in our lifetime, the pursuit of knowledge and understanding propels us forward, opening doors to new frontiers and expanding our vision of what lies beyond our home planet.